Welcome to The Explainer. Today, we're going to completely flip the script on how you think about keeping your applications online. We're taking that stressful, completely reactive IT mindset, the one where you're just constantly putting out fires all day, and we're upgrading it into a proactive, high-performing DevOps operation. So if you've ever felt like you're just literally one step behind your system's failures, well, you are absolutely in the right place. Let's get into it.
Okay, real quick, let's run through our roadmap. First, we'll hit the true cost of reactive monitoring. Second, what synthetic monitoring actually is. Then, 3 essential use cases, synthetic versus real user monitoring, shifting left in your CI/CD pipeline, and finally, we'll wrap up with observability as code.
All right, section 1, the cost of reactive monitoring.
Let's start with a scenario that pretty much every developer and SRE dreads. Imagine this: users can't log in, or maybe they can't search, or they literally can't complete a checkout. If you're only finding out about this when the complaints start rolling in, well, you're already in incident response mode. Relying on actual real-world traffic to find your failures means you're finding out way too late. I mean, discovering a bug because of a sudden spike in angry social media posts, that is the absolute worst way to monitor your digital experience. Basically, your customers are doing your quality assurance for you, and trust me, they are not happy about it. DevOps teams desperately need a way to catch these broken workflows before real traffic ever even touches them.
Moving to section 2, what is synthetic monitoring?
And this brings us to the hero of our story, the immediate solution to that massive reactive problem we just talked about. Synthetic monitoring is essentially your early warning system. Instead of sitting around waiting for a human to click a button and get an error page, you deploy a script that simulates that exact user action. It just runs continuously, maybe on a schedule or on demand from multiple locations. It's loading your pages, it's hitting your APIs, and it's completing those really critical user journeys. By actively measuring what happens during these simulations, your ops teams can spot configuration issues, broken dependencies, or just plain old performance degradation long before a real user is ever impacted.
Section 3, 3 essential use cases.
So how do we actually apply this early warning system to our day-to-day workflows? It's honestly easier than you think if you break it down into 3 distinct buckets to get a complete picture of your system's health. First up, you've got uptime and availability. Now, this isn't just a basic, hey, is the server turned on ping? It's checking your DNS resolution time and making sure your SSL certificates are actually valid. Second, we have API checks. These are scripts calling your key endpoints, validating the status codes, measuring response times, and even checking the payload to make sure the right data is coming back. And finally, and this is a big one, transaction or journey checks. This is where you simulate a full user experience, like logging in, adding an item to a cart, the whole 9 yards. This is what catches that incredibly frustrating scenario where a server says it's up, but the app is completely unusable for the customer.
But look, testing is really only useful if it actually tells you when something breaks, right? And alerting has to be meaningful. Otherwise, it just turns into background noise that your team totally ignores. So here are the 5 actionable alerts you should absolutely start with. You want to trigger alerts for repeated availability failures, not just a single random blip. You want to know when latency crosses a set threshold. You absolutely need functional alerts. For example, if a user's login succeeds but the dashboard just doesn't load, that's a massive failure. Don't forget your dependencies. If a third-party payment API is dragging, you got to know before users abandon their carts. And lastly, security signals. Something like an expiring certificate should trigger an immediate alert.
All right, section 4, synthetic versus real users. At this point, you might be wondering, wait a second, what about real user monitoring? Okay, think of it like this. It's robot versus human. Synthetic monitoring, that's your robot. It runs in a highly controlled, consistent environment. It's proactive, it's predictable, and it gives you a clean baseline to see if the latest changes you pushed actually improved performance. Real user monitoring, or RUM, well, that's the human side. And humans are unpredictable. They browse on totally varied networks from, high-end laptops on fiber down to older phones on spotty 3G connections. RUM tells you how satisfied real users actually are out there in the wild. The truth is, you really need both. The robot tests give you that clean, reproducible baseline, while the human data shows you the real-world chaos.
Section 5, shift left in CI/CD. Now, let's talk about how synthetic monitoring evolves from just being a dashboard tool into a core mechanism for seriously leveling up your deployment pipeline. We call this shifting left. Traditionally, monitoring happens way at the very end, in production. But by baking synthetic monitoring directly into your CI/CD pipeline, you literally shift that testing left. So a developer commits code, an automated build is triggered, and before it ever even sniffs production, your CI/CD tool invokes your defined synthetic tests. And the deployment, it only continues if every single test passes, no exceptions.
This pre-production phase is exactly where you want to be catching errors. Finding a performance glitch or a broken dependency while it's still just in the build phase, that is vastly easier and way cheaper to fix. Because once that code hits production, fixing it means patches, potential downtime, and untangling complex dependencies. Shifting left keeps your DevOps team happy, it keeps them productive, and it means they spend way less time fighting fires and more time building genuinely great features.
And finally, Section 6, Observability as Code. If you're looking to scale this proactive reliability across a massive global enterprise, doing it manually just isn't going to cut it. A lot of teams start out setting up their synthetic monitors manually through a UI, which is a practice we call ClickOps. It feels fast right out of the gate, but man, the cascade of risk it creates is huge. You get monitoring drift, where your staging and production environments just completely fall out of alignment. That inconsistency creates these dangerous blind spots where critical services fail silently, just because somebody forgot to click a button and configure the dashboard for a new feature. And ultimately, manual changes leave no audit trail, which is a massive compliance nightmare. So here's the crucial takeaway. If your infrastructure lives in code, your monitoring absolutely must live there too. By bringing tools like Terraform into synthetic monitoring, you define your monitors directly in your code repository. When a new service goes live, boom, the monitors go live with it automatically. Every single change is tracked in version control, which lets you standardize these checks across your entire organization. And that is how you establish true observability as code. When your monitoring doesn't move at the speed of your infrastructure, you're always one deployment ahead of your visibility. Honestly, that quote perfectly nails the immense risk of modern software delivery. If you can spin up infrastructure in 90 seconds, but it takes 3 hours to manually configure your monitoring dashboards, you are flying completely blind during your most vulnerable moments.
Which brings us to the end of our explainer today. I really want to leave you with this final provocative thought to chew on as you go back and look at your own DevOps pipelines. Ask yourself, is your monitoring genuinely moving at the speed of your code, or are you secretly still just waiting for your users to tell you when your system is broken? Thank you so much for joining me for this explainer, and I highly encourage you to start bringing those early warning robots into your pipelines today.